Hello everybody, welcome back to IZDWF repair bench, and we have another PET, Commodore PET. This should be a 4032, but it's a 2001N dynamic board, and by the number of the ROMs I think it's basic for unit. This has just arrived from a person that asked me to repair this PET, and so let's see what happens. It's quite a strange fault on the video circuit, but I can tell the basic started and there is a flashing cursor. So I think it's only at the moment. Well, I don't see cannot understand what is the bytes free amount, but basic should restart. Should be a ready prompt with a flashing cursor, but all the screen is garbled and doesn't make much sense. Now the owner said he tried to replace the video RAMs, the two 2114, and he said it didn't change anything. So I'm going to link a description how the character forming circuit on this kind of PET works, since I did that on a previous video on another PET repair. So I will link that video instead of explaining everything from scratch, how the character forming works on this kind of boards. So let's try to repair this board. Okay, first thing first, since we see meaningless characters, choose to verify the character generator ROM, and some check 7B67, which according to my notice on this PET, you have 10 7B67, so looks like the ROM is probably good. Another very interesting thing is that if we quickly turn the power off then on again, so the CRT is still hot, we can see the screen, the uninitialized video RAM before it's get cleared from the starting code in the basic and kernel ROMs. That's interesting because I don't know if you can see it, the characters are correct when they are random. The screen just gets mangled after the CPU clears the video RAM and start executing code. I will try to insert a still frame in the video if I can, so it will be clear that the characters are good when the RAM is not yet initialized. Actually had a better idea. If we don't want CPU to start executing anything, we can simply remove the CPU from its socket, and we get stuck with the random video RAM content, and that's telling a lot. We can see inverted screen characters, that means the video version works, but that was also evident from the flashing cursor in when the CPU was executing. We can see alphabetic characters and here like graphical characters, so both work from the character generation ROM. No flickering at all at any location, no location changing, so this is telling a lot of what works and what probably can have problems, but we can see that on the schematic now. So let's first look at the schematic of the number 8 of the 2001N computer, which is the video output part of the Commodore PET. What we understand from the random character screen we see with no CPU or when the CPU is not yet started is that most of the video output circuit is working, particularly the dot clock and dot shifter integrated circuit is working because the characters are still well formed and stable, no flickering at all. We also know that the video inversion circuitry is working, which is this one, because we can see both reverse characters and normal characters. We know that the character ROM is okay. We cannot see all characters in that random screen, but we see numbers, letters, lowercase, uppercase, also graphic characters, so it's okay. And the raw scanning addresses, which are 80, A1, A2, are also working, so all the circuitry that is producing the character scanning is working. Now in the schematic, and we have the character latch, which is UF8, and this one, well, for sure the outputs this side are stable, because this is the character address that selects the displayed character from the character generator ROM. So this is stable, at least when the CPU is not executing anything. We can start having doubt about this data bus, the screen data bus, that is derived from the video RAMs and from the CPU side, from these two buffers, drivers, that connects the screen data bus to the CPU data bus when it's needed. And we know already that the two video RAMs are good, because that was a first attempt from someone else when they tried to repair this PET. They socketed the two video RAMs, they tried to substitute with absolutely no change. So the video RAM are good. Also, because when the CPU is not executing, the random content is displayed fine, and it's not flickering at all. So, what are the possible problems? We could have unstable screen address bus, which is this one. But if that was unstable during CPU execution, I guess we would not see the write characters almost, I mean, the ready prompt, the basic banner, the cursor flashing, always at the same place. They are always at the same place in the screen position. So I don't think it's address flickering for some reasons, but this is a possibility that we have to explore, because when the CPU is not executing, the screen address is only scanned from the video output circuitry, and we'll see on another page how this is made. Another thing that is more likely, in my opinion, is a problem with this data bus transceivers. These two chips, E8 and E7, connect the screen data bus, which is that goes to the RAMs, to the CPU, the 6502 data bus. But this is only during read and write operations from the CPU itself. So if we have this signal, which is called TV read, then it means the CPU wants to read the contents of the RAM, and this goes low, and these two transceivers connect the RAM data bus to the CPU data bus in this direction, from the screen data direction to the bus data direction. Or when there's this other signal, which is called write, when this other signal is low, then these buffers are enabled in the opposite direction. So the CPU is outputting a data byte that is copied on this side of the transceivers, and is written to the RAMs. So this signal write also goes to the two RAMs, to the video RAMs, and enables a write cycle to these RAMs. So if there is a fault on these two signals, the enable or these two bus transceivers, then it may happen that some part of the data bus activity from the CPU is leaking to the screen data bus part, even when it's not supposed to be connected, and trash the whole screen. But let's have also look briefly on the screen address side on another page of the schematic. Okay, this is page 7 of the 2001 schematic, 2001N, I mean, and this is the other relevant page that we have to understand a bit for this repair. This part is generating both the write signal to the video RAM when the CPU wants to access, wants to write to the video RAM, and the read signal when the CPU wants to read from the video RAM. And these two signals also, as we have seen before, they enable the two bus transceivers in the correct direction for reading or writing. Then these three chips also are used for making the screen address bus, display RAM address bus, and this address bus is either the CPU address bus on one phase of this clock, or the screen counter
video scanner when to display the characters on the other face of the clock. These two counters are used to continuously scan the video RAM and to output the actual characters to the screen. So if we don't find any problem on the data bus of the screen data bus, we have to try to debug this multiplexer that form the screen address either from the counters or the CPU bus. What is when the CPU is not executing, these addresses from the CPU are of course not toggling, and also the data bus we have seen before on the CPU is actually three-stated when the CPU is not executing, and of course when the CPU is pulled from the socket, they are of course three-stated. So let's go to the actual board and have some checks on these signals and data bus.
Okay, between the two possibilities, I decided to investigate first the data bus possible conflict. And the best way to investigate bus conflicts is with current tracer probe. And this is UF7 RAM data bits, and I see no current spikes. This is UF8 data bits, and I do see the probe lights. I do see high current, and this is E7 data bus transceiver, and the probe doesn't light. But if we go on E8, you see the probe starts lighting, so it means it's getting high current. You see it's light every 2 pins because it's that when where the RAM is connected. If we go back to UE7, there is nothing, no current spikes. So the problem is probably indeed a data bus conflict. Now the enable signal for the data buffers is on pin 19 on both of the data buffers. So let's look like let's see what the signal look like on pin 19, and it's not very good. I mean, it's those spikes are not supposed to be there, and it's almost enabling going low enough to enable the transceiver, the data bus transceiver, but it doesn't explain why just UE8 gets enabled if this is a problem. And I think it could be also UE8 causing the problem on the enabled signal. It's difficult to see because the signal is produced by UF7 UF6 I mean, which has the good inputs and this bad output on pin 7. It's the same of pin 19, of course. So it may be UF6 that is bad, or UE8 that's causing noises on that signal. So I think I will cut pin 19 of UE8 and see what happens. So cutting pin 19 of the data bus transceiver didn't clean the conflict. which probably means that bus transceiver is bad, but also didn't clean the enable signal on the other transceiver, which is not conflicting anyway. So there may be more than one issue. Anyway, I think I have to remove and replace this 74LS244 anyway. With the lifted pin, it should not make any conflict on the bus, as it's still doing. So I removed the 74LS244 at UF8, but I didn't install a socket yet because in a previous repair attempt the two video RAMs have been socketed, and so I tried to remove the two video RAMs and without these 244, that signal that looked bad was still looking bad with the original 74LS157 at UF6. And it was only driving the remaining 74LS244 at UE7, I mean. But I didn't find any current spike on pin 19 of this UE7, so I decided this the old 157 should have been bad, and indeed with this new 157 here, signal on pin 19 looks nice and clean. And without the 244 we have a flashing cursor, no moving characters. Of course characters are wrong because there is no bus driver on the lower nibble. So I guess we are on the right track. So let me install a new 244. Okay, so now I replaced also UE8 with a new 74LS244, and success. Also the right amount of bytes free. So in the end this one, the original UE8 was conflicting on the memory data bus, and this one was really marginal. According to the data sheet, an high level voltage should never go below 2.7 volts, and this one was going below 1 volt, which was still recognized as a logic 1 by the other chips connected to the output of this one, but really this one must be changed because that pin driver can go bad anytime. It's already bad according to the data sheet, so anyway it was good to substitute it. And now, okay, this PET I will run a connect keyboard, disk drive, tape drive on both ports and check if everything is working, and I hope so, really. So as you have seen on the speed up video, I've checked both the tape ports, the IEEE interface to my disk drive, and this one first didn't work, so I tried just cleaning the contacts, and that solved the problem. And the last thing I usually test is the user port, connecting my laptop with CBM link and sending some programs. I like to use space invaders as a final test on PETs, and so everything works fine. The video problem has been solved by replacing two chips. I hope it was an interesting fault finding, and hope you enjoyed this video. And this is December 2019, and just a few days ago, a few weeks ago actually, Chuck Peddle passed away. So I wanted to dedicate this video to his memory. Chuck Peddle was the engineer, the lead engineer that designed the 6502, and one of the engineers that designed the Commodore PET. So he changed the lives of many people with a $1.25 CPU that costed a little fraction of the other CPUs of the time, and it changed also my life in some ways. So thank you for watching.